All right, everybody. My name is Clay. Welcome. I'm going to be teaching you all about Lewis structures today. So these are an awesome tool for us chemists, and they're going to be great for visualizing molecules and how they work and how they interact with the world around them. So talking about the why first, because the why is going to help us kind of facilitate why they're important, how we can learn about them. It's going to make it a little more important to us. There's only one reason why they're important, and that's because it tells us how the world works. Honestly, who wouldn't want to know that, right? So the reason it does that is because it tells us kind of how any and all molecules interact with each other and interact with different molecules. And that's really awesome and it's really cool. And while these are not going to tell us everything, they tell us a lot for just a simple little image. So with that said, let's learn about how we can do them. Okay, so I have an example written out here, and there's three main steps to learning how to draw a Lewis structure. The first step, the most important step, is counting up your valence electrons. So that's the total in the molecule. So if we look at this molecule here, we have CH2Cl2, right? So there's one C, two H's, and two Cl's. So I'm going to add up the total, and we're going to go from there. So if we look at our periodic table here, which we should always have, are we going to look at carbon? And we know that carbon has 1, 2, 3, 4 valence electrons. Easy. H has 1, but since there's 2 here, we're going to put 2. And then Cl has 1, 2, 3, 4, 5, 6, 7. 7 valence electrons. And there's 2, so we're going to add that up to 14. All right. So now that we know how many valence electrons we have in each individual component, let's add it up. All right, so that's going to be 20 total valence electrons. Okay, and now the second part, which I've already done because this is kind of just a little quick example. We'll do a full one in a minute. This is the mapping out of our atoms. So there's a carbon atom, two H's, and two Cl's. So carbon is going to be our centerpiece, as it is, and then everything else is going to branch off of there. All right. So what are these little dashes connecting our atom? Well, these are our bonds. These little dashes here that just draw my arrow to. Those are our bonds, and those consist of two electrons. Okay, so these two electrons are holding our atoms together, just like that. All right, these are electrostatic forces, just like a positive and a negative magnet that hold our atoms together. Pretty interesting. And so because these are holding us together, those occupy two electrons out of our 20 per bond. All right, so now that we've mapped this out, we want to satisfy the octet rule. And if you remember the octet rule, it's kind of what makes our noble gases so stable, our helium, neon going down. And so these are so stable because they have 8 electrons on them. And so just like those, we want each of these to have 8 electrons on it. All right, and so after we've drawn out our map, I guess, of our atoms and our molecule, it's important to now put on lone pairs and maybe even double bonds to satisfy the octet rule. So our carbon, remember, carbon here, we wanted to get it to 8. And how many bonds does it have off of it? We have 1, 2, 3, 4 bonds. All right, okay. And remember that each bond is worth 2 electrons. So our carbon is okay. Now our chlorine has 1, 2, 3, 4, 5, 6, 6 lone electrons plus 1 bond. And so that's going to make 6 plus 2, 8 electrons on it. And the same goes for this chlorine over here. So those both have 8, but what about our hydrogens here? What about them? They look like they only have 2. Well, hydrogen is unique amongst all atoms in our Lewis structures and just overall, and that it only needs 2 electrons to be okay. And in all cases, that's just going to be a bond. So as long as hydrogen has the one bond connected to it, it's going to be good. And that's what you should always look for, is that hydrogen just has one bond to it. All right, so that was kind of a fast run through of a Lewis structure. Let's do an example one so we can kind of get the hang of it ourselves. So I'm going to move this up here, just kind of cover up. Let's erase this. We have some room to work with. And now we're going to delete this. Sorry, I was covering my camera. And this is CCl4. So this is a little new, a little different. And so let's talk about what this is and how it works. Okay, so remember step one, count up our valence electrons. So we know that carbon has 4, and we know that chlorine has 7. So we say carbon, 4, and chlorine, 7. But we have 4 chlorines, so we're going to do times 4 here. All right, so that equals 28. Oh, I just drew an 8. My bad. 28, and then plus our 4. In total, we're going to have 32 electrons. So that's what the E minus is. So that's our electrons. So we have 32 of them. And now let's map out our molecule. So carbon is going to be the centerpiece, as it always is. And now let's do our CLs off to the side, branching off. Remember, always just draw it out initially with single bonds, and then maybe later on we do doubles. But we'll see in this case. And so now that counted for 1, 2, 3, 4 bonds. And that accounted for 8 electrons. So now we're down to 24 left. And so does carbon need any more? Looks like 1 bond, 2 bond, 3 bond, 4 bond. That should be 8. So carbon doesn't need any more. But our chlorines each need 6 more, seeing as how they have 1 bond on each. And now if we do our math, right, let's just draw 6 on each. Let's just try it out. And this is a great way to do our Lewis structure. Just kind of guess and check, right? See if something works. See if your intuition is right, because we can always erase it and go back later. So I drew 6 lone electrons on each. So that's going to be 6 times 4. And that's actually going to be perfect for us. And that's going to leave us with 0. And so this is the final structure here. And that's awesome. That was easy. And so that's a great starting place. As you go on, you're going to see that Lewis structures get so much easier the more you practice, but they're a skill you really need to practice. So in review, remember, 3-step process to do any Lewis structure. It's really easy. Number 1 is count your valence electrons, as we do on our periodic table. Always have that with you, and you should never not be able to. And then number 2 is map out the atoms, like we always do. Map them out with single bonds and go back in later. Right? Is step 3 to satisfy the octet rule, where we're going to put on lone electrons or double bonds in case that's necessary. Well, that's a lesson for a later date. Satisfy the octet rule, and you should have a completed Lewis structure like we do here. I made it look easy, but as you practice, it'll get so much easier, and hopefully you do practice and you'll get so much better and you'll know so much more about individual atoms and how they interact with other things and why they might do what they do. And that's really cool to see in the real world as you learn about it here. So I hope you learned something today. I hope you can now practice this skill a little better. Remember, my name is Clay. Thank you so much and have a good day.